predicate calculus. Example number one. Let's say you have the sentence: if it doesn't rain today, Ahmad will go to the beach. So in predicate calculus or first order predicate logic, it can be represented like this. So you have the function rain, and you have the today is the object, and then the second part you have the go as a function, and you have Ahmad and beach is the other two arguments. The second example, you have all volleyball player are tall. So over here you have the universal quantifier all. So you can use this one. Volleyball player X, everyone are tall. So you can use this quantifier. Some people like durians. So you have some people, you can use the quantifier, existence quantifier X, and you use the like durian, you can use the second predicate here. The fourth example, nobody likes war. So again, you can use for all, but you negate the for all likes here, not likes here, war, or you can use this one. There is non-existent of X likes war. So you have two options here to represent the sentence nobody likes war. Theory of what we call Aristotelian forms. Let's say you want to say all A's are B's, you can use this predicate. You can use the universal quantifier and this predicate in parentheses. Some A's are B's, you can use the existential quantifier, and you can use the connective and for all X, all A and all B. No A's are B's. This one you can use the negation of universal quantifiers. Some are A's are not B's. The word some, you can use existential quantifier, and are not, you can use the negation operator. So person P means you want to state P as a person. And if you want to represent the relationship between two arguments, so you can use the two object in the as a argument, and you have the action is the function name. Multiple quantifier, this is where you want to combine the use of universal and existential quantifiers. For example, every person loves someone else. So how to represent this as a predicate calculus? So you have every, that is a universal quantifier, and you have someone else that require existential quantifier. So more example here. You have Lucy is a professor, all professors are people, John is dean, deans are professor, All professors consider the dean a friend or don't know him. Everyone is a friend of someone. People only criticize people they are not their friend. Lucy criticized John. So some of these sentence require a universal quantifier or existential quantifier, or even the combination of universal and existential quantifier. So most of the example here cannot be represented using propositional logic, so you need predicate calculus to represent this sentence, this knowledge. So this example can be represented using predicate calculus like this. So how to prove EPOPL? It is not as simple as propositional logic. Propositional logic you can use truth table to determine the truth, but for predicate calculus or EPOPL you need proving. You need the deduction or resolution. So it requires a more complex steps to prove first order predicate logic or predicate calculus. So unlike propositional logic, you can use truth table. So in summary, in this lecture we cover two types of logic: propositional logic and EPOPL. So if you just want to represent a simple knowledge or static knowledge, so you can use propositional logic. But if you require complex and dynamic knowledge, then perhaps EPOPL or first order predicate logic is more suitable. As you can see in the slide, the second type of logic, which is first order predicate logic, is more expressive compared to propositional logic. But both propositional logic and first order predicate logic allow you to represent a new knowledge, or even to derive new knowledge from the existing knowledge.